Okay, this is the quick version of the histology slides for the gut and digestive system. This is starting with the esophagus. Just remember, these are always going to be thin slices, and in this case, it's like cutting across the wall of the esophagus, like slicing up the sausage. They're showing it here, and then you can see it up close. And what do we want to focus on here? Well, you've got a stratified squamous epithelium on the inner surface. That's basically like skin going all the way down your esophagus. Why? Because your esophagus is not about any absorption. It's about avoiding abrasion from the foods, much like abrasion on the outer side of your skin. So that's why you get that stratified squamous epithelium. No keratinized layer, that would be too tough. You got a submucosa with nerves and blood vessels in it. And then you've got a couple layers of muscle, circular wrapping around it and longitudinal to help squeeze food down there. All right, next slide. This is up close on just basically just the epithelial inner surface of the esophagus. Again, that stratified squamous epithelium. Um, this is showing also the esophagus in like cutting across there with the stratified squamous epithelium, the submucosa here, nerves and blood vessels, some connective tissues, and then starting to see the muscular layer there. Um, this is the stomach now. Remember, the stomach has these, so this is like this is the wall of the stomach that they've cut across. The food would be inside here, and you're looking at these rugae that stick out. You've got the mucosa, which is always going to be the um, what's it basically the epithelial layer lining the stomach. It looks kind of thick, but it's really a single layer of cells, but it's got all those gastric pits diving in, and then thick muscular layers, three layers of stomach in the stomach. Three layers of muscles in the stomach, longitudinal, circular, and oblique layers of muscles, and always that submucosa under the epithelium, providing nerves and blood vessels. This is up close on the epithelial layer of the stomach. You've got those gastric glands and the gastric pits. So it's like you've got this outer simple columnar layer of cells, and then these pits dive all the way down in here. And that's where you have the parietal cells that look kind of washed out, the darker staining chief cells producing hydrochloric acid and pepsin from those cells, the submucosal layer, and then the muscular layer. And this is even closer up on the gastric pits. You can see the nice simple columnar epithelial cells diving down, and then the pits kind of go down even deeper with here you're just seeing parietal cells. The gastric cells would generally be even deeper down. This is now small intestine. Just this is very high powered, as we've seen a lot of the small intestines, simple columnar epithelium on the surface of a villus here, and on the surface of that, these goblet cells, remember, producing mucus to protect the cells themselves from any digestive enzymes that's digesting the food that's in the small intestines. This is again showing, this is actually lower power, showing the the villi sticking out with the simple columnar cells on the surface. Um, there's further down, you get a some glands, and I don't think that's that important, but a submucosal layer as always, and then a circular and longitudinal layer of muscles wrapping around the small intestines again for that peristaltic action to move the chyme or the digesting food and liquid along. Another up close showing the nice villus with the nice simple columnar epithelial cells on the surface there. This is on the other hand showing a little deeper down, showing the two layers of muscles, smooth muscle cells around the small intestines. This is also just, I don't care too much about the different parts of the small intestines. This is now in the ileum further along. But what you see here, this is like a villus with simple columnar cells, not that different. But at the base here, you're seeing these nice Peyer's patches, which are collections of immune cells. They're like little mini tonsils or mini lymph nodes, if you want to think of them that way. There it is up close, close to where those intestinal crypts, you don't see so much more or less, but not to worry about. But really up close, these are all lymphocytes. So this is not really, this is not a epithelial tissue. It's one of those reticular connective tissues with lots and lots of lymphocytes organized on reticular fibers, which you can see laced throughout here, ready to combat any potential foreign invaders, like viruses or bacteria that might come across the wall of the small intestines in the food that you eat. Okay. Finally, large intestines. Mm, when you look at the epithelial layer, it looks real different because it has all these crypts. Crypts mean like almost like dungeons or crevices going down into the epithelial layer. And then the muscular layer looks different because you have the typical submucosal layer under the epithelium, and then in the muscular layer you have circular muscles going around, and then these thin, long tinea coli muscles that bunch the large intestines up into those house tree along the length of it. You can't see that in the slides. So this is cutting again across the sausage, more or less. The undigested food material would be out here above the epithelial layer. This is just showing up close to see how you don't really get those villi sticking out. You have like these crypts coming down into the large intestines with lots and lots of goblet cells to help, in this case, mucus, probably more to smooth things along because you're starting to form not such a liquid material in here, submucosa and the muscular layers. That's it for that digestive tract. The pancreas looks very different. It's mostly glandular tissue, and most of it is this acinar tissue that stains darker, lots and lots of cells producing digestive enzymes. Um, you can see some of the ducts here that collect those digestive enzymes, and they all come together to the pancreatic duct to take the enzymes into the duodenum, where the pancreas, of course, is nestled into that sea of the duodenum. The pancreatic duct goes in there. But you also see these islets, these different looking islands of cells in here. The pancreatic islets, where the alpha and beta cells that produce insulin and glucagon are located. Here's an up close of an islet of Langerhans, or they call them pancreatic islets, either is fine. And then still always lots of that acinar tissue that produces the pancreatic enzymes. Um, and finally, this is just one slide of the liver showing this really typical and very distinct kind of geometric look to the liver, typically hexagonally shaped liver lobules, which have in their center that very typical structure of the liver. Central is the central vein, where the blood that leaves or the liver drains into that vein. All the veins from the different lobules come together into the vein, the main hepatic vein, leaving the liver, joining the vena cava back to the heart. But remember, in these corners where you have a triad, it's not really easy to see at this magnification, but you would have those three different vessels there. A hepatic portal vein. Well, let's go with the hepatic arterial, a branch of the hepatic artery bringing oxygenated blood to the cells of the liver, and a hepatic portal venule bringing nutrient-rich, also potentially toxin-laden blood to the cells of the liver. Those two kinds of bloods will mix in these sinusoidal capillaries that all traverse. You can kind of get the sense that you're kind of traversing towards, you can't see the capillaries very clearly, but traversing towards the hepatic venule, lined by all of these hepatocytes. Most of this is filled with the hepatocytes that line the sinusoidal capillaries. This hepatocytes are going to produce bile, and there's tiny little canaliculi that make their way back to the triad and drain into the bile ductiles, and those bile ductiles all go together to the common bile duct to take blood and bile back to the gallbladder, and then eventually to the small intestines at the duodenum also. So that's what's happening in these sinusoids of the liver. Very distinct look to that histologically. And that is just a quick look at the histology of the digestive organs.